welcome to tutorial 3 of Cadence from CMOS EDU. And when we do this, we assume that you've gone through tutorials 1 and 2, so we don't seem like we're skipping steps. And we're also not teaching what the different layers mean in the CMOS process. You can read the CMOS book and get information on that. So let's go ahead and start Virtuoso. And let's see, we need to resize this window. Let's slide it down a little and over. And then let's go File, right click on this, Copy, Update Instances, and we'll call this Tutorial 3 Video. Okay, make sure you update instances, or the instances in the Tutorial 3 video will refer back to Tutorial 2, and we don't want that. We want this to be self-contained. Okay, where do we want to put it? We want to put it in Home, CMOS EDU. Okay, so we should be able to do this one fairly quickly. So let's create a new, so let's select Tutorial 3 Video, File, New, Cell View, and it went behind there, and let's call it Inverter, and give it a view of schematic. Say OK. Up pops the schematic. Now, one thing we haven't covered that I want to cover right now is copying. There isn't a clipboard in Cadence. It doesn't use the clipboard, so what we'll do to show copying is I'll go into the NMOS IV, open the schematic there, resize the window a little, hit F, press C, which puts me in the copy mode, or Edit, Copy. Then I'll select the NMOS 4 symbol and drag it over here. And if I can't see it when I drag it over into here, that means I'm in some command and I need to hit Escape before the copy will work. Drop it down. I'll close this window. Let's do the same thing for the PMOS now. Let's open the PMOS IV, open the schematic, press C, copy, go back to this window and drop it down there, hit F, close her up. Now notice our PMOS is 12 microns and our NMOS is 6 microns. Let's stretch this over a little bit. Okay. Then let's go instantiate, or I, and let's go to supply nets, throw down a ground, ground, and let's drop that there, and VDD, let's drop that there, then hit Fit, hit Escape, press W for wire. Yeah, let me make sure I'm drawing it the same as the tutorial. Okay, so let's press W for wire, connect a wire, press Escape a couple times and click. Now press W. Let's use this as an example. Let's zoom in. Let's press the tip, hit S for stretch, click again and pull it up. You can do the same thing with layout. Go back over here. Over there. Let's throw down a couple pins. It's hard with these teeny little, which is P. Input, let's call A. Press P. Call that an output. And we'll call it A inverse. And a little bit different than the okay, actually let's press Escape, press S, and then press S and press this and slide that in a little. We forgot the wire over here. Press W, come in here. Let's do a check and save. No errors. Okay, so now let's see, where are we at? Create cell view from cell view. and we want symbol, hit OK. Left pins, right pins, okay. There we go. It's nice and big. I'm going to make it small so I can see the CIW. Close this window for now. Select everything in here. Delete. Delete all this stuff. Now I'm not going to display the pins, but we'll check to make sure they're in the names of the pins when we're done. So let's go up and create shape line. Let's go up like this and just draw a little inverter. When we're done, we double click, create shape circle. That looks good. Hit escape, grab that, press move, and press click, create shape line again. Go over here, double click, select that object, move, well I guess hit move first. Hit fit, while that object's selected I'll press Q, and that sure enough is my output. Okay, so I've just drawn the symbol, easy. Okay, so now I need the layout, so I'm going to go close, check and save, close this, look at my library for inverter, and go to File, New, or whoops, let's do this. Right click, no, File, New, Category, no I don't want that, I want Cell View. File, New, get distracted. Okay, thinking of something else while I'm doing this. Okay, hit OK. We make our layout. There's our LSW. Let's shrink the size of the window. Hit F. Go press I. And let's browse to NCSU TechLib AMI06. Put down Metal 1 Poly, not Metal 1P. And then the other ones we want are NTAP, PTAP, PMOS, and NMOS. So let's put the Metal 1 Poly and drop that down. Hit escape, press I again. Let's put down PTAP. And I'm going to go ahead and put 2 columns, whoops, to make it a little bit wider. Just drop it down there. And then let's press I again, and let's put NTAP, 2 columns. Oops, didn't I cancel? Well, let's just place it, hit escape, select it, press Q, and then property or parameter, 2 columns. Okay. Then press I, and let's put down our NMOS. We could copy this from the other layout too and maybe save a little bit of time. Click in there, drag this down and make this 6 microns. Okay. Let's drop that like that. And last but not least, let's get the PMOS. Come down here. Set that to a width of 12. Oops, not 112. 12. Hide. And let's put it over on the side. Hit escape, fit. And you know what? Because we have such a tiny screen, I'm not going to handicap myself. I'm going to make this a little bit bigger. Move this stuff down. Oops, move it over. Move this out of the way. Move this till it's centered up. I think that's right. Hit fit. Move this up here. Shift Z zooms out a teeny bit. I'm going to zoom in and make sure that's in the right place. Ooh, I got it right. Okay, so select that one, press move, Let's move it down a little. And before I wire everything up, I think this is slightly different than what I had. Let me just DRC it. Verify, DRC, OK. And I can't see the CIW. Oh, good. No errors. It's a miracle. All right, so and I need to get the LSW now, so I'm going to have to adjust the size. And we'll still leave it like this. All right, so we're ready to wire this together. So let's throw down the piece of poly first, because I'm going to put my pins all in, metal. So I'll put down the metal and then metal pins. So I press R. I'm on the poly layer. And let me zoom. I just want to see something here. Okay. Let's drop this down. Let's drop this down. Then go back. Select metal 1. And then press R again. If we weren't already in that mode, hit Fit. Zoom down here. And let's just draw the metal like that. And while we're here, let's go ahead and connect these up, of course. Okay. And let's zoom in. I'm pressing Z and then zooming in just so I can see better. Fit. Zoom. Right there, I use the roller on the mouse button to zoom down there. Fit. And let's go ahead, oops, and hit escape, and then verify, DRC, OK. I can't see the CIW again, even though I didn't see any markers. Okay, we're lucky, no errors. Okay, so now, just to make sure it's clear, let's, oops, we don't need to do that. Press E for display. Go to stop level as 0. OK, and there we see how it's wired up. I didn't put any metal on here. Of course, you don't have to put metal over the metal that's already there, as I mentioned before. Okay, so let's go back and put that back on 10. OK. And then let's put pins in. So the VDD bang and the ground bang are both input-output pins, so let's do those first. So let's do VDD, shift bang, hide, zoom. Let's just draw the pin over here. And there's, like I said, a zillion different ways of doing this stuff. Whoops, what did I just do? Let's hit undo. Can't see the CIW, so let's try it again. Create pin. Oh, didn't I put the name in? All right, hide. Draw that over. Oh, guess what I didn't do? Let's do it one more time. I'm making a classic mistake. Create pin, display pin name, VDD, and I hit undo after I place those because I didn't see anything. Hide. Now we'll see the old pin, and if we still didn't, then what I do is I go back, press E, and make sure this pin name was showing. All right, so hit Fit, zoom down here, press I don't think the bind key works in the layout here. GND bang. And pin showing that time. Hit Fit. Let me try P. Nope. Alright. Create pin. A. And it's a input. If we don't select this right, we'll get a error when we do the LVS. Okay, so let's zoom in here. Drop this down, put that on there, go to pin, AI, drop this, oh you know what, let's hit escape, create pin, output, hide, we want it to work the first time, and this can be right there for the label, fit. Let's save it, verify, DRC, OK. Let's resize the windows. Not being able to see the CIW is driving me crazy. Alright, so we saved it. We did the DRC. Let's run the extract now. OK. Saving rep extracted. All right. Let's open that up. There's our extracted view. Let's go ahead and hit fit. Let's now run, let me make sure I'm staying on the track with the tutorial. Yeah, let's go ahead, and the LVS will be pointing to the wrong direction, but we'll fix that. I'll point it to the right direction, just give me a second. So we'll browse, tutorial 3 video, inverter, schematic, close, and then browse, tutorial 3 inverter extracted, close. See, tutorial 3 video, tutorial 3 video. You can get really frustrated if you don't pay attention to where these are comparing. Hit run. Says it succeeded. That doesn't mean the layout matches the schematic, so let's hit output. Alright, that does though. And mouse doesn't work there. Alright, looking good. So let's close the extracted view. Let's go back here, and I think we're ready to do the simulation. So let's go create a new cell, file, make sure on tutorial 3, file, new, cell view, and put it behind there. And let's call this sim, what did I call it? Sim inverter DC. And let's make it a schematic. Okay. First thing let's do is let's hit escape. Component browser, and we'll pull that up again in a minute. Let's instantiate in tutorial 3 video our inverter symbol. Okay. Hit escape. Now let's component browser, pull that back up. Actually, let's make it a little wider here. Let's go to NCSU analog parts, and let's go to supply nets ground. Throw that down. Hit escape. Whoops, escape. Let's copy that. Delete. Let's instantiate again. Supply voltage sources, VDC. Let's put a source voltage of 0. Doesn't matter. We're going to set it in the sim. Drop that in. And then let's add this other one. Actually, I did it different in the tutorial. Let me do it different here in the video. Let's, in the tutorial, what I did was I went to basic, miscellaneous, no connect, right click to rotate. I put this in there. Let's not do that here. Let's refresh our memories on how, if we have floating wires, how to get rid of the wire. So let's do a wire connection there, wire connection there, and let's hit fit. Let's do a shift Z, wire there, escape, L for label, or click on label up here, name, and let's call it in. Drop that down, out, drop that down, hit fit. Now when we do a check and save, it's going to say there's 2 warnings, and it's these 2 warnings here. And so we can go to check, find marker, and then just hit ignore twice, apply, and then close the window, check and save, and it goes away. Or, as I said a moment ago, we can go to miscellaneous, no con, rotate that, close this, whoops, close this, hit escape, let's delete this one, hit fit, check and save, and we're good to go. So let's remember we can go down and see this by going down in the hierarchy using descend, edit, shift X, OK. Or back in the hierarchy using B. Okay, so check and save. Everything's good. I think. No errors. It's hard with these teeny windows. Okay, so there's our schematic. Let's go launch the ADE. Session. Setup. Model libraries. We need to navigate to those. Let's go up. NCSU, Models, Spectre, Standalone, AMI 6. Okay, let's add another one, which is the PMOS. So now we have both of them. We hit OK. Let's see, now we want to, what did I do next? Do the analysis. So we do analysis, choose, DC, and you see the input source is V0. That's what we're going to sweep. So component parameters /V0. It's a DC parameter. And we're going to do a linear sweep from 0 to 5 in 1 volt steps. OK. And then outputs to be plotted. Select on the schematic. Let's plot in and out. And then, because we don't want to do this every time, let's do session, save state, cell view, OK. We hit roll them, netlist and run. And let's put it into strip chart mode, and we see our input goes linearly from 0 to 5 like we told it to, but our output stays at 0. And the problem is we didn't specify power to the inverter. Okay. So, if I go push down in here, which was, oops, cancel, cancel, cancel. Let's hit escape. If I push down in here, Shift X, okay, see I've got this power in the VDD, but I haven't defined it. Pressing B returns me. So what I'm going to do, I'm going to go instantiate in NCSU analog parts, supply nets of VDD. I'm going to drop it right here, which is going to give me an error. Hit escape, check and save, and it says one warning. And if I go look, check, find marker, it says I6 and I0 overlap by more than 10%. So that means, whoops, cancel. These two overlap by more than 10%. So let me move this one. Let's just move it right there. Then do another check and save. Now we still haven't told Spectre what the VDD is. So what I'm going to do next, I'm going to go into Setup, Stimuli, Global Sources, press 5. Now it still says off, right? So I'm going to hit Apply so I can see the DC voltage go to 5 volts. And I see, okay, whoops, oh, it's not enabled. Hit Apply one more time. And now I see it's on. Okay, so I don't want to have to do this every time, so let me go save that state again so it's automatically there next time I run the sim. So let's save state there. I could call it a different name at this point. I'm not going to. I'm just going to overwrite the existing state. Okay. Whoops, I don't want these on there, so let me get rid of those. Let me save the state one more time. Actually, you know what might be useful, which I didn't do in the tutorial, but I'll do here. Let's go to Outputs, to be plotted, select on schematic, and let's plot the VDD current. Okay, so let's go Session, Save State, OK, and whoops, OK, and roll them. Ooh, did I not specify, see how jagged that is? I must not have specified the step size in the simulation, so let me go fix that. Let's go back here. Start, stop, 0. Oh, step size 1 volt. That's not good. 1 millivolt. Let's try. And then plot, say plotted, cancel, yes, plotted, saved. Actually, let's leave it like this. Let's just hit go. I'm not going to save the state because I'm not going to post this. I'm going to post the one that I did in the written tutorial. Alright, that looks much better, and then we can use the strip chart, and then we could go back, select that, and plot it. Whoops, where'd we go? I'm not used to having such a small screen here. What did it say? Which does not evaluate to what objects can only be plotted. So let's do it this way. Let's close this and plot. I don't know why it's not letting me. Plot value. Let's try it one more time. I don't know, something simple I'm sure, but I want to finish this one with way less than an hour, so I'm going to stop there. There's lots of other examples at CMOS EDU. Okay, so let's do one more thing before we stop. Let's simulate. Let's see, simulation, netlist, display. We're simulating here the schematic. Let's go to setup, environment, and put extracted so we can simulate the extracted layout view. Hit OK. Roll them. What did that say? Which does not evaluate. Wait, what? Oh, let's get rid of that. I don't know what I did there. But let's plot, run. Okay, looking good, but I always want to make sure that I know what I'm actually plotting. So I go to simulation, netlist, and display, and there's my view name, extracted. And that's the end of the tutorial, and the stuff is saved on the written part. The zip of this directory, the one I used when I wrote the tutorial, is saved on the web page where this video is linked to. So let's hit